In today's video, we're going to look at how we can separate both soluble and insoluble solids from liquids, using techniques such as filtration, evaporation, and crystallization. Before we start though, I just want to point out some terminology. If we place a solid in a liquid and it doesn't dissolve, like if we put some sand in some water, then what we have is a mixture between a liquid and an insoluble solid. On the other hand, if we have a liquid and a soluble solid, so where the solid does dissolve, like if we put some sodium chloride salt in water, then what we have is called a solution, with the sodium chloride being the solute and the water referred to as a solvent. The first and simplest technique that we're going to look at is filtration, which separates insoluble solids from liquids. This is basically the same process as using a sieve to separate food when you're cooking. But in chemistry, we normally use filter paper, which has lots of tiny holes in it that are small enough so that water can pass through, but not solids. We often place the filter paper within a filter funnel as well, so that we can easily pour our mixture through it, leaving the solid behind on the paper. However, if we instead have a soluble solid in our liquid, and it's actually dissolved, then we have a solution, and this time we won't be able to filter it out. So here we have two options for separating a soluble solid from a liquid: evaporation or crystallization. For evaporation, we place our solution in an evaporating dish, or a crucible, which we normally place on a tripod, and then slowly heat it with a Bunsen burner. This will cause the solvent to start evaporating, and the remaining solution to get more concentrated. After a while, crystals will start to form, because it's so concentrated. And eventually, all of the solvent will disappear, leaving us with dry crystals of our solid. Now, the benefit of evaporation is that it's a relatively quick and easy way to separate solid from a solution. The issue though is that some solids will decompose when they're heated, which we call thermal decomposition. So even though we could use this technique to isolate our solid, we'd end up breaking it down into something else. This means that for solids that are susceptible to thermal decomposition, we have to use a slightly slower technique called crystallization. The first step is still to place our solution into an evaporation dish and heat it, but this time we need to heat it more gently, so we might use a water bath instead of a Bunsen burner. Then, once some of the solvent has evaporated and we start to see crystals forming in the solution, we stop heating it and leave it to cool. As the solution cools, more crystals will start to form, because solids are less soluble at colder temperatures. Next, we'd have to filter out these crystals from the remaining solution, using filter paper and funnel. And then the last step would be to dry our crystals, by either leaving them somewhere warm or warming them up in an oven.